Well, this would be kind of like kindergarten compared to what we just previously saw. Don't ever get friendly with Brad because he will Shanghai you into just about anything. But I thought we'd kind of go over how we made the Chinese balls using the kit that I have fabricated. First thing is to make the ball. And the biggest issue here is to make that ball as concentric as possible. And tolerances of 2007 inch is not out of line. Second thing is to make the ball the correct diameter so that it fits the chuck nice and tight, but not overly tight. And there's the tolerances. What I normally do is, when I'm turning a ball, is I actually use the chuck as the final test to make sure that it's going to fit properly. Everyone wants to know how you cut that nub off the ball after you turn it with a sphere cutting tool. Typically what I do is mount it into my Chinese ball chuck, set it off center, set the sphere cutting tool back in alignment with the ball, and basically cut the end off. And you end up with a very nice shaped ball. When I first started doing this, when Jean-Claude did his presentation at the previous symposium, I talked to John, and he made this sound like the easy part, the cutting the actual hard part. What I have found out is laying out those 12 holes is without doubt the most difficult part of cutting the ball. The actual cutting itself is quite simple. First thing you do is you identify a point on the end grain, and then you basically draw a circle using one of the formulas for dodecahedron and all that stuff. And we're not going to go into that at this point, but basically you draw a circle and then you divide that circle into 5 equal parts. Sounds very simple. After you erase it about 25 times and start over again, you finally get it where you want it. Then you take those 5 points and you draw intersecting lines to come up with a second set of 5 points. And then from that, you draw the 12th point. That's when you realize that you, after I tried it several occasions using one of Jean-Claude's fixtures, I finally called him up in France and said, "How do you do this?" He said, "Well, when you get done," he says, "you have to fudge a little bit." That is kind of an understatement. You have to fudge a lot, but the bottom line is you want 12 holes that are very, very accurately distanced from each other. Once you get that, well, let me back up here. Once you get that, then you draw the outside diameter of each one of the holes so you know exactly how large to cut the holes. And you start by installing it into your chuck. You use the center point on the tailstock as the exact center for that hole. And I normally do a little indent in each one of the centers of the holes so that you can use that tailstock to kind of push it into the chuck and line it up. Then you simply install the flange on there to hold the ball into the chuck, and you tighten it up. You tighten it up nice and snug, but you don't over tighten it. It's amazing how tight or how tough the ball is actually inside the chuck. I've had 12 holes cut and you can't crush that ball. Then you install the tool holder platform, and the only thing really critical here is to make sure that the top of the tool, your cutting tool, is at dead center vertically. That is extremely critical on cutting the ball. And then you take your bidan, you put it into your tool holder, and you start plunging it into the ball. You go to the left hand of center. You only cut with the end of the bidan, you don't cut with the side. You continue that until you get your tapered hole, and from that point, then you start installing your, there's a finishing up the hole. You cut it to that outside diameter, and that's why it's so critical to mark those outside diameters of the holes when you're laying out the ball. Ask me how I know. Once you get that done, then you start with your cutting your grooves. You start with the inside groove, or what I refer to as cutter number 1. You start on the extreme right-hand side of the ball. You slide the cutter in, and is there a pointer around here? The most critical thing is your tool holder must ride against the edge of the ball. And you simply swing it around to the left, and you cut the first groove. You swing it back to the right, you put the next cutter in, you cut that groove by swinging it to the left, swing it back to the right. You do that with all 6 cutters. There's the cutter swinging over to the left. And if you notice that the tool holder is basically burnishing the edge of the ball. If everything's done right, when you get done, the outside edge of the ball does not need to be sanded because it's nice and smooth.
Charles, what speed are you running?
Thank you. I typically turn the balls about 1,000 RPM. I've gone everything from about 500 to 2,000, and 1,000 is ideal. You got to remember, basically, you're doing a scraping action here. For you guys, the dyed-in-the-wool cutters, you hate to hear the word scraping, but it works. You do the 6 cutters, and then once you get your 6 grooves cut, if you want to embellish the outside edge of the ball by cutting a bead on it, you do that. I use the D-Way tools by Dave. They're absolutely phenomenal tools to cut that outside bead. At this point in time, you want to go ahead and sand your hole, sand the surface around the bead, because once you get done with this, you never want to try to reset it into the chuck again. David Springett talks about taking the ball out and doing it and resetting it and resetting. Gentlemen, if you've got that much time, you need to find something else to do. Once you cut a couple of holes in the ball, and typically I will cut hole number 1, which is at the end grain, and then I cut hole number 12, which is at the other end of the ball, end grain, because that's where you have the most strength left as far as the surface of the material is concerned. But once you cut about 2 or 3 holes, you have to start plugging those holes, because those inner spheres will start vibrating on you, and you'll have a disaster on your hands. Following Jean-Claude's recommendation, and just about all the guys in Europe are doing this, use dowel board, 1-inch dowel insulation board. You simply make a cone with your plug, you stick it into the hole, kind of twist it in, and you cut it off, and then kind of trim the outside edges, and you press it into the hole just as snug as you can get it. After you pull these plugs out, you'll be amazed at how the cutters will cut the 6 grooves in the foam. But the one thing that you don't want to do is have that foam projecting out to the point that when you install the ball inside the chuck, you get a piece of foam between the edge of the ball and the chuck. Once you do that, you do it with all 12 holes, and you remove the plugs, and you can sand what little needs to be sanded at that time. I was talking to Al earlier. He has one of my kits, and he sticks a little piece of sandpaper in between the first and the second layer. You hit those inner layers with an air chuck and at an angle, and those inner balls would just spin like crazy, and it's like using a power sander to sand the inside balls. This particular ball has satellite holes cut into it. If you're going to cut satellite holes into the balls, you want to do that before you actually start cutting the 12 balls. And that's how you make a Chinese ball.